What are the bounds of this damn thing? Should be from like negative 7,000 to 7. I hate these fucking numbers. 72,000? It's like I just want to see how wide this thing is. But you can't read these numbers because they're so fucking huge. It's like 36,000 to 50,000, so it's like 100,000 units wide or something. So this needs to be like, 20,000 or something. That's incorrect. There's absolutely no way that the distance is that low. Well, I'm just going to keep debugging all this stuff. I don't understand. Like, from everything I've been looking at, I've got the right numbers. But then they're not the right numbers, so I mean, where is the damned issue? Like, I guess the big thing there is, it's not going from 0 to 1, it's going from like, it's not doing that at all. It's just like, why wouldn't the middle be white? and the step is just like all sorts of trash. Yeah, not really super. Floor is deprecated. Use floor to int instead. Wait, what the fuck? Oh, don't tell me there's some crap like that going on where they deprecated some math function and literally the floor function doesn't work. Hello, Kento456. How are you doing today? I am again constantly frustrated by math. Trying to do a distance calculation. This is pre-computed distance. The problem is this distance is not quite what I want. I'm trying to get it a little bit better. Alright, what is that? It's x, y, res x. Where's this distance buffer? And then something's right after it. Propagation. 255? What? Why is that 255? Shouldn't it be 0? Oh, Jesus Christ. Okay. I think I know what I was doing wrong there. Oh, God. That's such a stupid mistake. Well, that's what you get for using magic numbers. I was passing 255 in as the default propagation value, so it was basically for every single pixel that wasn't colliding with something, it had a 255 put in there, which is a very small amount, which would completely fuck up all the distance calculations. Shit. Well, there's your problem. You hooked up the engine to the exhaust pipe. That's not where gas comes from. Alright, well I'm gonna leave this this buffer in here because it's actually a little bit more flexible to do this distance buffer for later. Good morning, Karakan. I am terribly vexed as usual. What I'm working on right now is I'm working on a pre-calculated short distance map. So what that means is you can look up in the texture how far away you are from the shore. So we can, do stuff based on the distance to the shore, not just the depth and stuff like that, right? Also, hello, Lucas. Welcome. How was you were sailing, right? How was sailing? All right, we will see. And I am horribly hungry at the moment. My stomach is eating a hole through my everything. Alright, so we're looking at this map. We want to make it like 512. We want the shore distance to be like, 1,000 or something. $2,500. Let's see, 5,000. About 10,000. Well, that looks like a distance calculation that is smoothly interpolating. Like, it is looking like it. The diagonal values look a little strange though, don't they? Like, the diagonal values are falling off faster than you might expect in some ways, I think. Like, I would expect those to be smooth going from 0 to 1, but I guess maybe they are smooth going from 0 to 1. It's not, it's... The distance is... Maybe the distance is wrong. I suppose I could blur it or something like that. Alright, so I'm going to go to my water stuff here, and I'm going to plug the alpha in just to see how the alpha on this texture sample is going to be the height map. So the height map would be 0 at these locations that we have here. It just doesn't look smooth. It looks like something's wrong with their distance, isn't it? Like this should be a circle, right? Not a weird thing. Oh, this is what's going on. Yeah, okay. It's not a circle because of our iterative approach. We should be calculating our distance based on... Oh, okay. I know what's going on. You're on a sailboat? That's pretty awesome, Lucas. I hope you're enjoying yourself out here. Alright, so the reason that we're screwed up right now is because we are currently calculating our distance using this algorithm where we kind of walk along this thing, and what we're doing is we're adding the distance here, and then we're adding the distance here, and then we're like adding the distance out here, and like all this sort of stuff, and that's not the fucking distance. The distance is from this location to this location, not this distance. You know, like this distance here is longer than this distance, so what we actually have to do here is I need to calculate the distance each time based on like the x and the y, and then after everything else is there, then I'll apply the step values. So yeah. So we need like the location, and we also need the cost. This is definitely a situation where we have so many parameters to this function that I've forgotten a few. Alright, so what we want to do is, what we're writing in here is we're not going to be writing in the we're not going to be writing in the float distance. We're going to be writing in the value of the pixel that we are coming from. So we're going to calculate our distance each time, and it's going to be like, we're going to have like int32 start x and int32 start y. And what we're going to do is basically, this propagation doesn't matter, because we're going to have float distance equals like our fmath absolute value of start x minus x multiplied by x step, and no, it's stupid power functions. Alright, so we're going to want, our vector is going to be our x minus start x, and then y minus start y. And then our distance is going to be multiplied by x step Alright, so our distance is going to be this value. Why is this getting all pissed off? Alright, so if current distance is less than or equal to propagation, current distance is going to be distances, yeah. Distance is greater than max shore distance. Yeah, we got start x and start y. So I think this is pretty much what we're supposed to do here. Is we just need to calculate the distance each time that we're walking along this thing. At 800 kilometers. There I am sitting. Yeah, you guys are practically on the same boat. Alright. Closing in on not being an idiot. At least for 5 minutes. Now I basically had this just wrong with my pixel distance. I had the cost proper, but then I didn't have it. Like, cost and distance are different things. And basically I was using the wrong thing. So it was overestimating the distance, overestimating the cost for moving to a certain location. And that's why things were looking all weird. So we can actually clean up this code quite a bit once we get it set up properly. It's no distance compared to the US. Yeah, this is true. Alright, let's see what we're actually getting here. Alright, so distance is x minus start x, x step y, start y. So distance is going to be 0. Alright, so basically, yeah, we need to calculate if this pixel actually needs to be searched, is what we need to calculate here. So if direction, yeah, if current height equals 0, if direction does not equal 0, then we can just return distance equals 0. Otherwise, yeah, it's basically if direction equals 0, if current height equals 0, does not equal 0, then return. And then we do this distance check here. Alright, so basically we're going to break out of this loop immediately if No, we can break out of this loop regardless. So if direction is 0, if that doesn't equal 0. Otherwise, if the current height equals 0, else if current height equals 0, return. So it's like, okay, if you run into a pixel that has a distance value on it, alright, otherwise we can calculate this sort of stuff. So we grab our current distance from there, we get our vector, and the problem before was we were setting the distance to 0, and everything was saying, oh, well, the distance to myself is 0, so I should be fine. And instead, we should be only checking the distance to the start x if the start x and start y were actually a black pixel. Doesn't that look better? Doesn't that look like a smoother transition between shore and not shore? One might think that's true. Why do we have these weird artifacts? Doesn't seem right. Or you could think that those two would blend together, not be mutually exclusive. Alright, so if distance, current distance is less than or equal to distance, alright. Alright, if the direction is 0, if the current height does not equal 0, then get out. Otherwise, if the current height is 0, exit. Alright. And this should expand in all directions. And we don't use this propagation, do we? Yeah, we just use it there. Yeah, let's get rid of unnecessary variables here. Alright, the propagation, get rid of that. Alright, so what is this algorithm doing at the moment? Oh. That's incorrect. I was not using the y coordinate, I was using only the x coordinate for my distance calculation. Well, that's a problem. I think I just added that bug and got rid of it real quick. If the distance is greater than the max shore distance, then the current distance equals, then we're going to return, and it's going to be white. If the current distance is less than distance, then we're not going to override it. Well, let me think. Is there some sort of issue here with distances? Or we're gonna get some artifacts. I'll have to think about it. I mean, I would absolutely expect, like, these shouldn't combine, that's true. But they shouldn't have a line right in the middle of it. Like, these should be smooth fall off as this goes out. But these distances are incorrect, is what it looks like. Does it have to do with the scale of this thing? Make it a square? I mean, it's like we've got the wrong diagonal values going on here. Like the our distance formula isn't working on diagonal values. That's just what it looks like to me. Otherwise, you know, it's like it's going out farther than it should based on diagonal movement. Well, let's just remove some of our heuristic rules and see if it's some of our rules that are screwed up. And I'll have to really drop down the size of that texture. Otherwise, it'll take 2 million years to calculate. So let's do a 64 by 64 texture. I mean, you definitely wouldn't expect these sorts of like dots to be inside. I mean, we'd expect just a freaking gradient, you know? What the hell? Is there some sort of issue where we're like stopping our... Yeah, you'd almost want to have this thing run. Like, this should just be... Damn. Alright, so the two times, it's really these conditions. The current height A equals 0, return. So we're opening every pixel all over the place, but for some reason, if current distance is less than distance, if distance is greater than max shore distance. Well, let's just turn off some of these other things. Well, I don't know what I'm doing anymore. We've got our step X and step Y, so our scales should be set up properly. We're calculating our distance based on that value properly now every single time. But for some reason we are getting these modeled things, which is like stuff getting set to stuff either not getting written to for some reason. Alright, what are we doing here? So let's just get all this stuff. We're just going to go through for every pixel and just write this thing out and see what it looks like. So you got our y diff and all that, so we'll have float distance equals x diff times x diff plus y diff times y diff left math square root. Alright, so if the current written distance is less than the distance here, then don't write. If the distance is greater than the max shore distance, then current distance equals max shore distance. Why would we return? Well, let's just take out the return. Alright. Because what might be happening is we're short-circuiting something because some distance value is changing. I'll have to just look at it. Maybe there was a zero issue here where if current distance is less than distance. We need these protections back so we don't go over the same pixels again. It may have been that we were running into like a 0 pixel and stopping our distance formula or something like that. Well, I'll eventually get this figured out. I don't know, I feel like I'm really overcomplicating this. This really shouldn't be that hard. And I'm just doing something real stupid.